In this question, we have two springs, A and B, and we are given a spring constant, K, of 2.5 newtons per centimeter. And so they're attached rigidly. They're horizontal. When they're at rest, the extension of each spring is 3 centimeters. So if there is an equilibrium length, this thing is stretched, has a delta x equal to 3 centimeters. And this one has been stretched 3 centimeters. Then the trolley is displaced 3 centimeters to the right. So we add 1.2 centimeters. So this delta x becomes 4.2. And this delta x goes from being 3 to 1.8. 3 minus 1.2 is 1.8. Now, if we were to calculate the force of the springs up here, we have a spring constant of 2.5 and an extension of 2.5 centimeters. So the forces are 7.5 newtons. This is the positive direction. That's the negative direction. Then this experiences a force of 7.5 newtons, and this is negative 7.5 newtons. And of course, the sum of those forces is 0. The cart's at rest. But now we have a different thing going on here. And this is what it asks us to do, is to find the force on spring A. And it wants the magnitude, so it doesn't care about the direction, but we just want to be aware of that. So the force of spring at A is Kx, and K is 2.5, and X is 4.2. And when we multiply those, we get 10.5. So the magnitude is 10.5, and the force itself is minus 10.5. That's on spring A alone. And if we were to do B, the force of the spring on B, well, that's Kx, and K is 2.5, and X is now 1.8, giving us 4.5 newtons. And so that is the force of the spring. It's positive, so we don't need to think about the direction at all. Now the trolley is released, and we are asked to determine the initial acceleration of the trolley when we have this mass. Well, we can use our dear old friend Newton's second law. F net is the sum of the forces. F net is ma, and the forces we have acting are force of the spring A and force of spring B. And therefore, the acceleration is force of spring A plus force of spring B, all divided by the mass of the trolley. Force of spring A was minus 10.5. Spring B was plus 4.5, and the mass is 0.75, which gives us minus 6 over 0.75. And that works out to be minus 8.0 meters per second squared. That's the acceleration. And that means to the left. And that is question A23.